what I try to get off, because maybe something is wrong with our display connection, so that is what we need to check, and therefore I try to get this PCB out of the housing to be able to do a better inspection. But before we go ahead, I recognized that the ribbon cable over here is not really in its connector, so it looks to me that it is really canted. So let's try to align it a little bit, maybe that this is already the problem. Okay, so I have corrected here our ribbon cable, how it sits in its connector, and of course for testing, can we see it here? Maybe that way. It's a little bit dark. For testing, I have of course here our ribbon cable, our second one, connected back to a display board, and now only for testing it is easy to put it here on, and yeah, let's see what we have. Hello! Yeah, so it is back. So my assumption was definitely right. It really lost its connection in the socket, so that was the whole problem. And I've heard it quite often that it happened to radios like this, and now we can be sure it is not really a serious problem. It is not an expensive fault. It is simply the little connector here in or on the display board. And of course I was interested in the question if this little connector down here is or has really good solder work, and I can definitely say that all the connections, all the solder work down at this connector down here is excellent. So we really do not have an issue down there. It is definitely only this ribbon cable. Yeah, it is a little bit short, and maybe if yeah, the handheld is placed to different temperatures, or if it fell down or whatever, so maybe that it got out of its connector. So that might be the reason why it lost connection. So everything else is just fine. I will now bring it back into original condition, and then that should be fine. And if it is working, then you know how you can fix this issue. Alright, so it is back in its housing, so I only need to put back here all the knobs and our antenna, of course, and here the belt clip, and so forth and so forth. But basically you see, yeah, it is definitely back working, and very important when you put it back together, don't forget the rubber sealing. That is very important, that not any water is getting into it. I mean, it is not waterproof, but if you're outside in the rain or what have we, then it is definitely good to have this rubber sealing. So don't forget to put it back. And yeah, now let me assemble here the rest of what we need to do, and then we are ready. Okay, that's it, already the end of the video. So that is the widescreen solution for TYT, Retevis, or however these radios are called or named. So that is a widescreen solution, and I hope that is something what can help you out in the same way I've done it here. Okay, thank you for watching, and catch you next time. Bye.
また来たか、大阪。まずはチェックインか。よっしゃホテルズ.com。これでもう一晩大阪で過ごせるぞ。
あら、ダンディさん、出張でまた大阪来はったんですか？
今月はこれで10泊目。
ほら、あれよ、ゲストやね。
あれ？今回の宿泊で何かあるというの？この大阪出張で何かありそうだね。あー、広いベッド。これは家のベッドよりも心地がいい。なんだか急に腹が減った。大阪は賑やかだ。この活気、不思議と孤独に感じない。何を食べようかな。
ちょっと、そこ何ボーっと突っ立ってんのよ。あ、お腹空いてんねんな。あげちゃん、あげよう。ちょっと、やないやろ。もうジョークやがな、ジョーク。もう兄ちゃんが構える、うちらが打たれる。お腹空いてんねやぞ。とこあんねん知ってる私。行こう。行こう。よしね。行こう。一杯飲んだら一杯無料か。いいな。欲をそそる。あ、いかん。仕事で来てるんだった。雰囲気に飲まれるな。まずはビール。してはりますね。にしても楽しそうだな。この活気と笑い声がなんだ。うまい。あれ？いつどうやって帰ってきたんだ？それにしても昨晩の楽しい時間を覚えていないなんて悔やまれる。ああ、もう一泊できたらな。よっしゃホテルズ.com。ホテルズ.comで一泊分の無料宿泊を。
Hi and welcome to Xbench. Well, over the time I had a lot of requests if I could show how to test a receiver, and yeah, that is what I try to do today with very first video. on testing a receiver, and well, let's start with the easiest way to test a receiver, because you know, for testing a receiver the only thing you need is a signal generator and an audio voltmeter, and with this both instruments you are already able to test for signal to noise. And yeah, let's start with this easy testing, and how we have to connect, you know, the radio and the test equipment, and then let's see what we really can do with the result, what does it mean, and maybe then you see how really easy it is to do so. Okay, let's right go to the bench, and let's start and see how it works. Okay, so let's simply start with the question, what is noise? And you see here on the bench so that is my testing device. When I need some output power to drive a linear amplifier or whatever. So, you know, so that is here my little workhorse. And you see it is already switched on, and there is no antenna connected to the radio. And now you already hear it. That is the noise or static. And if your ears are already trained a little bit, you might hear that something is funny here with the signal, because it is not only the normal known noise. So additional to that, we have some hum. So do not really know if the camera microphone is able to catch it, but you can clearly hear that beside the normal static, the noise, there are some it is hum, distortion, which is added to the signal. So try once again. And that is not normal, and so we want to see what that is as well. But first, now, I mean, we have heard noise, but so what does it mean? How can we test it? How can we understand what's really going on? Okay, so let's first connect our radio to a tester to understand a little bit better what's going on. So first, so what I am doing first, you see me using here my little, I have called it SSB Lab monitor, but in the basic setup it is a speaker and a dummy load, and I can switch here between speaker and dummy. And what I do always first is to connect here the radio. You can't see it. With it a little jack here, audio jack, I connect, if you like, an external speaker, and now it is connected here to my external speaker, and now you recognize that the sound is here coming from my external speaker, and of course I can switch it here to dummy. So that means I only change from the speaker to a dummy resistor. In our case it is of course 8 ohm. And how does it look like? So normally it is nothing else than what I have here. So one hand our little audio jack, and here I have two alligator clips, and this here is an 8 ohm, let me see, so that is an 8 ohm resistor, right? So you can easily clip it here to you know, our wire here, and that is now exactly the same. You can do all testing here in parallel to our dummy resistor, right? So whatever we do, we always do it at a dummy resistor like this, and that is exactly what I have here in my little lab monitor. So for the moment in time it is switched to a dummy, or of course I can switch it back here to a speaker, alright? And that means I can use what I need to use, speaker or dummy, so it always depends. But you also can do it here, so you can disconnect here your dummy resistor, and instead you connect a little speaker to here your test lead, and that's it basically, right? And on the other jack here, my output jack, so that is what I already told you. It is again exactly what we have here in parallel. I pick here my signal, so that is the whole secret. So really nothing special. Okay, as we already heard, there is hum still, and now when I told you this is noise, let's see how this looks like on a spectrum, on an audio spectrum analyzer, to see or understand a little bit better what I mean. Okay, so I've just here unplugged the radio, so here our input is open, so we do not have a signal present at our lab monitor. And now let's go over to our spectrum picture, that we can talk a little bit about that. Okay, and here it is, and as we all know, a spectrum analyzer is a very, very sensitive instrument, so you always see spikes and what have we, because you know, a spectrum analyzer is able to listen to fleas, you know, and therefore you see here all the movement. Okay, now I connect the radio back here to my little lab monitor, and you see our audio is turned completely counterclockwise. So we have here minus 100 dB full scale, and you see it is more or less flat, but as I said, there is no audio on for the moment in time, right? Now I increase the audio, and you will hear it, of course, in the speaker, and suddenly you see and you hear that our red line, and now I switch it to dummy, that we do not hear this annoying audio. And yeah, as I explained, now we are testing in parallel at the 8 ohm dummy resistor. Yeah? And what we see here is that our noise level is getting up, right? So we hear noise. And as I already discussed, and as we already discussed before, it sounds a little bit funny because there is hum in the background. And here on the spectrum we already see that at 100 Hertz we have here a spike, and that is a distortion. And that is what we clearly can hear in the audio, and I can tell you what it is. It is my LED light is doing this. So that is a cheap Chinese LED light, and it is producing a distortion, and you clearly see it and you hear it. And for instance, if I go now over to the light switch, and when I switch it off, have a look. Now the distortion is gone. I switch it back on, and you see all the spikes are coming back. So that is a very, very bad LED light, producing really a lot of noise and heavy distortion. So if you have LED light like this close to your Radio Shack, right, you always have this distortion, and this distortion is able to really eliminate your signal you want to hear on the radio. So all these LED lights are very critical. Anyways, now we really have here only noise, okay? And of course I can change the level here on our spectrum analyzer by simply changing the volume. So now, don't know if you hear it in the background. It is not very strong. Now I increase here my audio, and while I increase my audio, you see it is coming up. And you see a second point, or a second issue. You see that suddenly here at 5 kilohertz our signal is going down. So here we have 5 kilohertz, and you see here over, I don't know, here from 100 hertz or from 200 hertz, whatever, up to 3 kilohertz, it is more or less flat, and then suddenly you see that the noise level is going down. And that is simply because I have the CCITT filter in. So the CCITT filter is something we have, of course, present at our Rohde and Schwarz radio communication tester. It is present at the CMT and as well on the CMS. So on both I'm able to switch in the CCITT filter, and that makes the audio more in a range where you normally hear a voice, right? So we do not need the very high frequencies, so the CCITT filter just reduces this area, which you definitely do not need for receiving a radio signal, and therefore you can prepare your tester to only display the range where you normally hear a radio on receive. So that is sometimes very helpful, because for instance you see here little spikes. I mean, this little spikes here at what is it, 15, 17 kilohertz, so these are not very strong, so you wouldn't hear it. But on the other end, there could be, for any reason, spikes which are more dominant, and therefore it is nice to have a filter like we have it here, to be able to reduce those distortions. On the other hand, radios I mean, our communication sets, our shortwave radios, are normally having an internal filter as well. So normally you are not able to have a very strong audio signal at 10 or 20 kilohertz. So your internal filter in your shortwave radio is normally reducing these parts of the audio signal as well. So the CCITT filter is only an addition to what you already have in your radio. Okay, so again, what you see here is noise. And coming back to what we discussed before, we just want to understand what is now the signal to noise ratio, okay? And why can we use it as indication? And therefore it is helpful to see it first on a spectrum analyzer to have a visual idea on what's really going on. Okay, so the next step is I have now connected my signal generator to the radio. You might have seen that the radio is adjusted to 14.1 megahertz on the 20 meter band, and for the moment in time I'm not putting out any power to the radio, and that is the reason why we still, and you can hear it, we still have only noise, so there is definitely no signal. Okay, now I leave here the speaker on, and I switch on my audio generator, and the radio is set to AM, so additional to that I use a 30% modulated AM signal, and always when we are testing, we are using, not always, but most of the time, we are using a 1 kilohertz audio tone, right? And that is what I've adjusted here, 30% modulation, and 1 kilohertz audio tone. And that is what we now send, if you will, to the radio, and the radio needs to receive the signal and needs to demodulate the signal, that in the end at our speaker we can win back our audio, because that is what we want. So on our transmission we have high frequencies, so that is how we carry our audio signal to distant end, and at distant end, at the receiver, we have to bring back or win back, if you will, our audio signal, and therefore our receiver needs to amplify the signal, and the signal, the high frequency signal